Artificial neural networks. Let's explore how to build and evaluate artificial neural networks, ANNs, using Keras. Artificial neural networks are the fundamental algorithms behind many artificial intelligence systems we encounter in our daily lives. Keras is a Python-based deep learning library that facilitates the easy construction of complex neural networks. So, let's get started. First, we will look at the process of installing and loading the necessary packages to use Keras. To install the Keras package in R, we enter the command install.packages Keras. Once the installation is complete, we load the library and execute install_Keras to set up the TensorFlow backend. Since Keras provides powerful deep learning capabilities through TensorFlow, this step is essential. To confirm that everything has been installed correctly, we check the version of TensorFlow by printing it out. This allows us to verify that TensorFlow has been installed properly and that Keras is connected appropriately. Now, we move on to the step of generating random data. We will create a data frame consisting of 1000 random data points with two features, x1 and x2, along with a binary class represented by y. This data serves as the foundational material for training the model. To enhance the performance of the model, we normalize the featured data to values between 0 and 1. Normalization adjusts each feature to have the same scale, facilitating faster and more efficient learning for the model. Next, we split the entire data into training data and testing data. We will use 80% of the data for training and the remaining 20% for evaluating the model. This splitting process is important for determining how well the model generalizes to actual data. We will build a simple sequential neural network using Keras. The first layer will consist of 10 neurons, and we will use the ReLU activation function. This structure helps the neural network learn non-linear relationships. After constructing the model, we set the loss function to binary_cross entropy and choose the atom optimizer to compile the model. The loss function measures the difference between the model's predicted values and the actual values, guiding the learning process to minimize this difference. Now, we start training the model. We use the training data, along with 20% of the total data as validation data, to evaluate model performance in real time. We will monitor how well the model learns the data over multiple epochs. Once training is complete, we evaluate the model using the test data. We check the loss value and accuracy to gauge the model's performance. These values are crucial indicators of how accurate the model's predictions are. Now, we perform predictions based on the test data. We check what classes the model predicts from the data and output the results to intuitively assess the model's performance. We use a confusion matrix to compare the prediction results with the actual labels. This information helps us identify the model's strengths and weaknesses and can be useful for finding additional improvement points. We have explored how to build and evaluate an artificial neural network using Keras. By applying appropriate data pre-processing techniques and hyperparameter tuning, we can further enhance the model's performance. The R code is posted in the community post.